Every time you download software from the internet and run it, you're trusting that the binary you received is exactly what the developers intended and that nothing was tampered with along the way. In Bitcoin, there's a saying, don't trust, verify. Today, we take that literally. We'll compile Bitcoin Core from its raw source code in 6 commands, so you know line by line exactly what your node is running. Two key terms before we begin. Source code is the human-readable text that makes up a program. The instructions a developer writes. A binary is the compiled, machine-executable version of that program. Compilation transforms one into the other. Building from source means you control that transformation. Let's start by getting the code. Here's our 6-step pipeline. Clone, autogen, configure, make, test, install. Step 1, clone. Git is a version control system that tracks every change to a code base. The command git clone, followed by Bitcoin's GitHub URL, creates a complete local copy of the entire project history on your machine. Every commit, every branch, every release, all on your hard drive. Step 2, choose the right version. The repository contains every version of Bitcoin Core ever released, each marked with a tag, a labeled snapshot of the code at a specific point. You select a version with git checkout followed by the tag name. Here's the critical distinction. Some tags look like v25.0. These are stable production-ready releases. Others have an RC suffix like v25.0 RC1 or v25.0 RC2. RC stands for release candidate, a pre-release build meant for testing. Release candidates may contain bugs that haven't been found yet. Never run one on a production node. The rule is simple. Always pick the highest version number without an RC suffix. For production, you'd run git checkout v25.0. Before building, you need certain libraries and the tools installed. The Bitcoin Core repository includes detailed build documentation for every major platform: Linux, macOS, Windows, FreeBSD. Check the doc directory for your operating system. It lists every required package. If you skip this step, the build will fail later, but the error messages tell you exactly which library is missing. Install it and continue. Steps 3 and 4, autogen and configure. Run autogen.sh first. This script generates the configuration files your build system needs. Then run configure. Configure interrogates your system, checking your compiler, installed libraries and available features. If something required is missing, configure stops and names the problem. Think of it as a pre-flight checklist. Once configure passes, your system is ready to compile. Now that you have the basic pipeline, let's look at the choices that matter. The configure command accepts flags that customize your build. 3 you should know. First, a prefix equals home Bitcoin. This installs compiled binaries into a custom directory instead of the system-wide US local. Use this when you lack admin privileges or want Bitcoin isolated from other software. Second, disable wallet. This skips wallet compilation entirely. Choose this for relay-only nodes, block explorers, or any setup that doesn't manage private keys. Third, without-gui. This skips the cute graphical interface. Use this on headless servers where you interact only through the command line. A real-world configure command might look like walk-a, configure, prefix home Bitcoin, disable wallet, without-gui. Each flag removes code you don't need, producing a smaller, more focused binary. Step 5, make. This is where compilation happens. The make command tells the compiler to translate every source file into machine code. On a single CPU core, this takes up to 60 minutes. To speed it up, add the J flag with your core count. The command make J with mproc in a subshell automatically detects how many cores you have. On an 8-core machine, build time drops from 60 minutes to roughly 8. If the build fails, don't start over. The most common cause is a missing or incompatible library. The error output names the exact dependency. Install it, rerun configure, then run make again. Make resumes where it left off. It only recompiles what changed. Once the build succeeds, run make check. This executes the unit test suite, catching obvious breakage before you deploy to a live system. Step 6, make install. This copies the compile executables, Bitcoin client, and others into your system path. Right? If you use the prefix flag earlier, the binaries go to your custom directory and no sudo is needed. Step back for a moment. What you've done is exactly what thousands of developers do to audit Bitcoin's code. The 6-step pipeline, clone, autogen, configure, make, test, install, isn't unique to Bitcoin. It's the standard build pattern for virtually every open source C or C++ project. Learn it once and you can compile the Linux kernel, Tor, or any GNU tool the same way. The deeper point, running software you compiled yourself is the highest standard of verification. You didn't download a binary from a website and hope it was legitimate. You took the publicly available source code and built it on your own machine. Your compiler, your build flags, your binary, there's a level beyond this, right? Deterministic builds, where multiple independent parties compile the same source and produce byte-for-byte identical binaries, proving no one inserted anything extra. That's a topic for a future video. For now, you've taken the foundational step. Don't trust, verify.